Okay, so I have my circuit from the last video, and I'm going to turn the switch off so it can stop running. And I'm gonna change it up a little bit. So this is a battery and a resistor. So let's at least add another resistor to this. So I'm going to just swing this down to the right. I'm going to change this to maybe 12 ohms. Doesn't matter at this point. Let's pull down another resistor. I'll just draw a couple of them in here. Come on, and one more. Okay, escape, escape. I'm going to bring this up here. That connected. That's nice. I'm glad to see it does that for me. So I can drag components to the node, and it should connect it for me. Let's see if I can drag this one back. Well, it's good, but it's not that great, I guess. So I'll just wire this one in right here. Okay, so now I have a series connected circuit. So why is this important? It's one of the fundamental circuit types that we just have to understand. So a series connected circuit means that the current from the battery has to go through all of these components to get back to the battery. So let me change these resistors to 12, just a low resistance. And 12 is an odd number, but so let's turn on the switch. You can see the current flows through all of these components, right? Let me see if I can break this circuit. I'm going to try to make it malfunction. So I'm going to click on that and delete and try to run it. So this is an open circuit. An open circuit happens when I don't have a continuous path back to the battery. Okay, so if you were to build this type of circuit and turn it on, it won't do anything because there is no path for the current to flow back to the battery. So if you measure the voltage at this point, let's add a scope to that point. You can see that the voltage is, well, it's showing 0, and that doesn't make sense. It's not really 0. Let me delete this. Let me add a voltmeter to it. Okay. Let me just throw a voltmeter in there. So it is a simulation. So some things act a little different from what I would expect them to do, but let's try to work around that. I'm going to draw just a straight line back to that point. And let's close that switch. So it does work. If I have an open circuit like this, the battery voltage, which is 12, will show up at every point in the circuit because there is no return path for the current flow. So let me draw another voltmeter, and I'll put it down here. Let me connect this to the ground point, and I'll connect this one to that point. Okay, and you can see it's also 12. So when you measure your circuits, if you're trying to build a series circuit like we did in one of our projects, and you get the same voltage everywhere, that tells me that you have an open circuit. So if I close this circuit with a wire, now the voltage drops and this voltage drops because there's a continuous path back to the battery. So the voltage across the component is related to the resistance and the current through that component. So this is known as a voltage drop right here. And V is I times R, 0.33 times 12, which is 4. This voltage here will be this voltage and this voltage. And since they're the same resistors, it's 8. So if I have 3 of any value, you'll get like an even distribution of voltages across the part. Okay? And that's actually an important concept. The voltage drops have to add up to the supply voltage. So let me change the supply voltage. How about if I make it 24 volts instead? These voltages go up as well because I have more voltage to start, and I have more current now because I have more voltage in the system. So the current is related to the voltage and also to the resistance of all these components out here. Okay, so I have to stop this video. I'm running along with it. So this is a series connected resistor circuit, and you can see the current and the voltage at different points. So that's a nice simulation.